So this is our third lesson. This is about branch connections. So in this topic, we will discuss more about remote access connections. So what are the different options that can be used for small to medium-sized businesses. And then part of the discussion also is the PPPoE, or the point-to-point protocol over Ethernet. So we will explain how point-to-point protocol over Ethernet operates, and we will do some basic demonstration on how to implement this PPPoE connection on a client device. Part of the lesson is the VPN, or the virtual private network. So we will be describing what are the benefits of using this VPN technology, especially in some private companies. Okay, and also we will have the GRE, or much more specifically is the GRE tunnel. So we will discuss this and we will have some demonstration about this GRE tunnel. And lastly is the BGP, or the border gateway protocol. So let us describe the features of this BGP. What is this BGP all about? So what are the different variants of this border gateway protocol? So then if you are ready to discuss this topic, then let's get started. Okay, so let us discuss remote access connection. So what are the available connections that we can have from our internet service provider? So we have here the cable system. So it uses coaxial cable that usually carries radio frequency signals across the network. So in here, the internet service provider is using a typical cable system. Okay, so mostly these are coaxial cable that installed in the area, and then as you can see, this type of connection is mostly a shared connection between the different subscribers. There are two important cable components for this type of internet connection. So we have the cable modem termination system, or the CMTS. So mostly this equipment is reside from the subscriber. And then another component is the cable modem. So this is actually the hardware that reside mostly on the subscriber. So all of these components must work so that the cable system internet connection will work as well. Good thing for DSL connection is that each subscriber can have their dedicated or direct connection from the internet service provider. So that kind of connectivity is possible by the use of DSL access multiplexer, or DSLAM. Okay, so this hardware is reside mostly on the internet service provider. Okay, so that's one of the component of the DSL connection. And then other hardware is mostly located in the subscriber side, which is the transceiver. Okay, so usually a modem in a router which connects the computer of the teleworker to the DSL. So this is the transceiver. So this is like a modem that are used also in the cable system. So these are the example hardware that you can might encounter in reality. So this is the DSL transceiver. So the physical look of the equipment might vary in actual. Okay, so this is the equipment reside in the premise of the subscriber, and this is the DSLAM. Okay, so this is the equipment mostly reside in the service provider. So this equipment composed of electrical components and transmission line, and the terminating interface of this hardware mostly are enclosed in a enclosure box. Okay, so that it will have a physical security. So this is the important hardware component okay, of the central office, so that the DSL connection is possible. Okay, there are a lot of options that we can actually use when it comes into wireless connections. So we have municipal Wi-Fi. So most municipal Wi-Fi or wireless networks use a mesh of interconnected access points. Okay, so like this one. So they are in mesh connections. Okay, so that it can cover a large area. That's why they call it municipal Wi-Fi. Then we have the cellular or mobile. So this type of connections mostly used by mobile phones that have a radio waves to communicate through nearby cell towers or cell site. So the cellular speeds continue to increase. Okay, so as of now, we are using 4G or 5G, and then although the other country are starting using 6G. Okay, so probably in the future we can have also the 6G version of the cellular Wi-Fi connection. So in LTE, okay, category 10 supports up to 450 megabit per second download and 100 megabit per second upload. Another type of wireless connection is the satellite internet. So used in locations where land-based internet access is not available. So primarily installation requirement is for the antenna to have a clear view toward the equator. So this is much more advanced and sophisticated wireless connection setup. Okay, so using the satellite. Alright, so maybe one of this day in our country, so all of the ISP will be required to have a subscription to those satellite providers. Okay, so ISP need to come out with that kind of internet connection so that it can boost the speed or the quality of our connection. Okay, so I'm not trying to promote some ISP companies here, especially in our region, but this is an example of a satellite kind of connection when it comes into our internet. So one of the common provider that we have is trying to talk with the satellite provider, which is the SpaceX. So this is just an example so that you can at least you can see, or at least you can have an idea what is the satellite type of connection. So in here, the ISP is not necessarily required to have their own satellite, so but at least they can outsource or they can subscribe to other satellite provider like the SpaceX. So this one it can be one of the solution so that our internet connection will be boost up, okay, and it will have a very good speed in terms of bandwidth. So one of the area in our country have their municipal Wi-Fi. So this one is an example from Manila. So an example of implementation of municipal Wi-Fi. Okay? And the other source of internet connection, which is the cell site or the cellular mobile internet connection. So these are example of a tower from our different internet service provider. When it comes into internet connections, there are a lot of options or technologies, although these solutions are not all available in a specific region like in our country, but let us have a quick comparison of this broadband technology. So let's start with cable. So this is a shared type connection. Okay, so that's why slow data rates during high usage hours. Okay, and another is the DSL, the digital subscriber line. So this one is limited in bandwidth, okay, and it's also distance sensitive. alright, in relation to the ISP central office. Then we have the fiber to the home, requires fiber installation directly to the home. Alright, so as you can see in the image, so this one is an example of a fiber installation. Then the cell site or the cellular mobile type connection, so coverage often an issue, especially in some other remote areas or provinces. Okay, then we have the Wi-Fi mesh. Most municipalities do not have a mesh network deployed. Okay, so although we have an example, so but not all the city or municipality have their own Wi-Fi mesh connection. Then the satellite, expensive from the side of the internet service provider, and then limited capacity per subscriber. So because there's a what you call it, channel or limitation in the channel when it comes into the interconnections between the ISP and the satellite itself. So let's move to the other part of the lesson. So now let's proceed to PPPoE, or the point-to-point over Ethernet, or let me say point-to-point protocol over Ethernet. So mostly in the customer equipment side, okay, so there is an Ethernet frame in the part of the data, and then when the transceiver receives it, it will strip it off, and then it will just continue to transmit it going to the other side, and that is the ISP or the internet service provider. So therefore, it allows point-to-point protocol frames to be sent across the Ethernet cable to the ISP from the customer's router. So this is an example of point-to-point protocol over Ethernet configuration from the subscriber side or equipment. So mostly we just configured encapsulation point-to-point protocol. Okay, and then for the IP address via DHCP. Then after that, we will just have the following authentication. So we will be using CHOP as an example here, and provided with the other parameter like the hostname and the password. Okay, and then next, the dial pool 1 is actually required. Okay, so it should be matched with the point-to-point over Ethernet client dial pool number. So mostly this is a basic configuration of PPPoE from the customer side. Okay, so what is important here is we must have our interface dialer here. Okay, so we need to assign a number. Alright, so a valid number will do, and then of course the PPPoE enable. Alright, so it should be issued in the configuration, and then lastly the value for the maximum transmission unit, which is 1492 in our example. It depends what will be the MTU. Alright, so but this one is used for the transmission limitation capacity. Alright. Okay, so let us have the example of point-to-point protocol over Ethernet. So let us have a simulation. So in here, I have two routers. So this is 1941. So let me call this as the subscriber router, or let us say customer router. Alright. Okay, so customer router. Okay, so customer router, like that. And this one is the ISP, okay, or the internet service provider. Okay, so let us have the configurations. Okay, class, so let's start the configuration, okay, of our PPPoE demonstration. So let's start with the subscriber equipment. So of course I will not no, okay, So let me first assign the host name, which is the customer router or device. So it can be like that, and then interface G0 1, no shutdown. Okay, so I want to bring it up first. Okay, and then for the ISP, but in the reality you will not totally do the configuration for the ISP, okay, including the subscriber device. Alright, so although some of the other companies they have their network administrator, so mostly they are the one who can coordinate or who can actually work with this kind of configurations. Okay, so but before enable, so I want to have the enable, and then config T, and then host name ISP R1, okay, something like that. And then the interface, so I will bring it up, then no shutdown. There you go. Okay, so now let's proceed with the configuration of the point-to-point over the Ethernet. Okay, so let me start with the ISP again. Alright, so for this one I will assign a username. Okay, so let us call it customer1. Okay, and the password, let us say Cisco PPPoE. So this one is just an example, but in reality you should be careful with the password assignment. Okay, then next is the local pool. So some sort of similarity in DHCP, but this one is not totally DHCP. Okay, so let us call it PPoE pool. So let us have the assigned IP address from this range. Okay, alright, there you go. And then we can proceed now to the next part. So let us have the virtual interface. Okay, so we can have the following. So interface, let us call it virtual. Okay, let's have it template 1. Okay, so there you go, we are now in our virtual interface. So let me assign the following IP address. So IP address, okay, there you go, and then 10.0.0.254 the subnet mask. Okay, so let us continue, although I encounter some problem. So but first let me have the following command. So interface G or the gigabit ether 0/1, let me assign the IP address. So the IP address assigned is 10.0.0.254. okay, so it's /24. Alright, so let me reissue the command, no shutdown. So now let me exit, and then interface virtual template 1. Okay, so let me reassign the IP address or the IP address of 10.0.0.254 255.0. okay, okay, so still this command is not recognized under the interface virtual template 1. So let us have some alternative. Okay, so let me exit. Okay, and then let me re-enter interface virtual template 1, and then followed by IP unnumbered. Okay, alright, and then this one followed by the our physical interface, which is 0/1. Okay, so let us have this alternative for the configuration of our ISP router, so that we can resume the demonstration. So again, this is the problem here. So the command is not recognized by the virtual template 1 interface, our virtual interface. Okay, so now let us have the peer. We will not be assigning maximum transmission unit this time, so let us proceed with the next command, which is peer default IP address. Okay, so coming from our pool. So remember, we have our pool name earlier in our configuration, so it should be match. Okay, and then the PPP authentication. All right, so which is CHAP, and then there you go. Okay, so and we have the exit. So there you have it. So this is the partial configuration for our PPPoE in the side of our ISP. Okay, so let us continue the configuration of our point-to-point protocol over Ethernet. So this is our ISP device. Okay, so this one is connected to the switch via gigabit Ethernet 0/1. So let us continue the configuration. So let me continue by exit. Okay, and let me save all the configuration that I have previously. So now let me re-enter. So config T or configure terminal, and then this command. So let us have this one. Okay, so this is BBA group. Okay, so that is PPOE. Okay, global. All right, and then this is the virtual template 1. Remember that, and then exit. Then let us get it the gigabit. Let us enter. All right, there you go. And then the PPPoE enable group global. Okay, so this one global, and no shutdown. There you go. Okay, so let me save, copy, run, start. There you go, and then show running. Alright, so let us check. So we have the virtual template 1. Okay, and then this virtual template 1 is actually reside, as I'm said, into our G01. There you go. Okay, so now let us proceed to the customer side device. So this is the router of the customer side. So let me enter the configuration. Okay, so config T. There you go. And then let us have the following interface. So let us have dialer 1. Okay, so let me try MTU. Okay, so 1492. There you go. And then the IP address, it should be negotiated. And then the encapsulation is PPP. And then the dialer pool, remember, from the ISP it should be 1. And then the PPP authentication, let us provide it into our customer side device. So it should be the CHAP, and then remember the parameter Colin. Alright, there you go. And we have the CHAP hostname. Okay, so let us have cos1, and then the CHAP password for this is Cisco PPPoE. So this one is also declared into the ISP side equipment. And let us exit, and another exit, and then let me save this first. There you have it. So show running. Okay, so we have the dialer 1 configuration. Okay, so let us continue. So this time let me configure the static route, okay, of the customer router. So by having the following command: IP route, okay, default route, and then so it should be quad 0. Alright, there you go, and dialer 1. So that will be our exit interface going to our ISP. Okay, all right. And then lastly, of course, let us observe our PPP event or activities by having the following command: debug PPP authentication. Alright, and the debug PPPoE events. Alright, okay, so let's try. Okay, so let me try one more time. Debug point-to-point protocol. Okay, or let us have the following question mark. Okay, so it's not here, so maybe we can have PPP. Okay, so we have the authentication, then let us have the packet. There you go. Okay, so let us do some observation about this configuration or connection. So let us have the following. So interface config T, then interface. Alright, so there you go. So we receive an alert, or let us say a message here from our dialer 1. Okay, so let's say interface gigabit ethernet 01. Let's try to shut down, and then let's say have this, and let us observe the reaction. Okay, so maybe let us turn it on. Alright, so again, so from our dialer 1. Okay, so basically that's it. When you want to have your configurations or connections using the point-to-point protocol over Ethernet. Okay, so again, this is our topology. So let us fast track. Okay, fast forward. Alright, there you go. It's all up and running. Okay, now let us proceed to the next part, which is the VPN or virtual private network. So many companies use this kind of internet connection for security and privacy purposes. So that's why VPN is a private network created via tunneling. So that is the logical connection, okay, over a public network, which is usually the internet itself. A secure implementation of VPN with encryption, such as the IPsec VPN, so it's usually meant by virtual private networking. So for you to have the implementation of this, so a lot of hardware that you might consider. So you can have your router as your VPN gateway, or your firewall, or even the Cisco Adaptive Security Appliance, or the ASA. Some of the organizations use VPN. Okay, so the following are the benefits, alright, of having a VPN in the connection. So the first one is cost savings, where the VPNs enable organizations to use cost-effective high bandwidth technologies such as the DSL. Then scalability, organizations are able to add large amounts of capacity without adding significant infrastructure. Next is compatibility with broadband technology. And lastly is security, where VPNs can use advanced encryption and authentication protocols. A VPN gateway is a device that is responsible for the encapsulation and encryption of the outbound traffic. So that's why site-to-site VPN is possible. So in site-to-site VPN, end hosts send and receive normal TCP/IP traffic through a VPN gateway. Okay, so as you can see in the figure, this is the VPN gateway. It can be a typical router, or it can be a firewall. In site-to-site VPN, the requirement is a hardware gateway. But in remote access VPN, the client must have a software, okay, installed on their machine. Alright? Because remote access VPN supports the needs of telecommuters, mobile users, and extranet traffic. Okay, so used to connect individual hosts that must access their company network securely over the internet. So that's why in here, mostly the users or the telecommuters, okay, required to have a software-based VPN client so that they can be able to connect to the VPN terminating device of their company. Another type of VPN, which is the dynamic multipoint VPN. So actually this is from Cisco, a solution for building multiple VPN. Okay, so especially if the company have multiple sites or branches. So as you can see in the figure, so this will be the solution for them to have the interconnection using the VPN technology. So this one is possible by the use of the following protocol, okay, and encryption. So the first one is the Next Hop Resolution Protocol, or the NHRP. So mostly this is just a distributed mapping database of public IP addresses for all tunnel spokes. So meaning to say they have their public IP addresses configured on each tunnel or on each devices. Another is the multi-point generic routing encapsulation, or MGRE. So it's an interface that allows a single GRE interface to support multiple IPsec tunnels. Okay. And lastly is IP security, or IPsec encryption, that provides secure transport of private information over public network. Alright, so IPsec mostly works here during the transmission. So it will secure the tunnel because the tunnel reside in the public connection. So that's how VPN works technically. Okay, so DMBN or DMVPN can be used by many companies having multiple branches or sites. So let us have an example of implementing GRE. So generic routing encapsulation. So that's the meaning of that. So as you can see, we have a figure, okay, depicted here. So we have a router 1 connected to the R2 by a tunnel, which is the GRE tunnel. Okay, so let us analyze the mapping of IP addresses. So serial 000, so we have 209.165.201.1. So that is the assigned IP address for this interface. Okay, then the tunnel 0 facing the R1 is 192.168.2.1. Alright, for the R2 we have the following mapping of IP address. Okay, serial 000, we have 198.133.219.87, and tunnel 0 facing R2 is 192.168.2.2. Okay, so let us have the following steps. So step 1, create a tunnel interface using the interface tunnel, then followed by the number. So this is now for R1, this is the interface tunnel 0. Okay, then step 2, configure the IP address for the tunnel interface. So as you can see, 192.168.2.1 for the tunnel 0. Okay, so there you go. So this is /24. Okay, but before that, we have the tunnel mode GRE IP command. The next is to specify the tunnel source IP address. The tunnel source IP address is 209.165.201.1, which is the IP map of serial 0/0/0. And the target destination, okay, is 198.133.219.87, which is the IP address mapped into the serial 000 of R2. And of course, we have the routing protocol here, the OSPF. So let us declare the following: 192.168.2.0 as the network under area 0. So this is actually referring to our tunnel 0 IP network. Okay, next is after that, specify GRE tunnel mode as the tunnel interface mode. So this is an optional. So now let's proceed to the R2. So again, we have the interface tunnel 0, the GRE IP, and the mapping of IP address of tunnel 0 facing the R2, which is 2.2 as you can see here. And of course the target source, so that the target source is, our source is 198.133.219.87. Then the target destination is 209.165.201.1. And of course we need to enable the OSPF as our routing algorithm using the 192.168.2.0. So remember, the IP address of the tunnel is always private, usually private, because this is referring to our local area network IP addresses. Okay, and the IP addresses assigned mostly on the serial interface of the device is always public, or an IP address coming from the internet service provider. Alright, so we have an example GRE implementation here. So before we start, let us check some of the configuration that we have on our router devices. Okay, so let's start with RA device. So as you can see, G00 with the following IP address, and the serial 000 with the following IP address. So they are all up. Okay, so let us trace the connectivity. So G00, so that's from going to our PCA, and serial 000 going to the internet. So that's 64.103.211.0/30. How about the next router, which is RB? Okay, alright, so show IP interface brief. Okay, so we have G00, so 192.162.1, and then serial 00. Alright, so they are both up. Okay, so let us trace that. So that is serial 000, so that is 209.165.122.0/30 network going to the internet. Then the G00 going to the local area network, or PCB in our example. Okay, so let us have some basic connectivity tests using the ping command, or the ping tool. So let us ping the S000 of RA router using the following IP address, which is 64.103.211.2. Okay, so that's belong here. So let us have the connectivity test using the following IP address. Okay, so that is 64.103. Alright, so maybe let me move this one here. So there you go. Alright, so ping 64.103.211.2. Okay, so success. Alright, okay, then how about the PC? Okay, so we want to ping PCB from PCA. So let us check the IP address of PCB. Okay, so IP config. So the assigned IP is 192.162.2. Okay, so 2.2. Alright, so let us check if working. So ping 192.168.2.2. Okay, so it seems like the communication is not working, so there's an issue with the tunnel. So let's work with the GRE, okay, for this demonstration, and we will test it again later after we configure the GRE related commands. Okay, so let's start the configuration of GRE tunnels. So we're having a problem between PCA and PCB. Okay, so let us have the configuration. Alright, so let's start with that, the RA router. Okay, So config T, and then let us have interface tunnel 0. Okay, and then after that let us assign an IP address, so which is 10.10.10.1, and using the following subnet mask. Okay, so enter. So 10.10.10.1. Okay, so that will be the tunnel, or the GRE tunnel that we want to create between RA and RB. So as you can see, we have an indication here in our topology. Okay, alright, so let us continue. Then after that, let us have tunnel, okay, source, so which is the serial 00. Okay, serial 0/0/0. There you go. And the tunnel destination is 209.165.122.2. okay, so let us trace where is that 209.165.122.2. so actually that is the IP address assigned to our RB, serial 0/0/0. Okay, alright, so let us proceed with the configuration. So next is tunnel, okay, mode, okay, GRE IP, and then no shutdown. Alright, and then exit, and then let me save. Okay, alright, so after we configure the RA device, so now let us configure also the second router, which is the RB. So this time we will be using the 10.10.10.2 as the tunnel IP address, and the target destination, alright, so it will be the 64.103.211. that's something of RA device. So let us check the serial IP address of our RA device by using the following command: show IP interface. Alright, so that is that too. Okay, so let's start the configuration of our second device. Okay, alright, so config T, so interface tunnel 0. Okay, and then IP address is 10.10.10.2 based on our topology. Okay, so this is 10.2. next is, after that, okay, of course don't forget the subnet mask, which is 252/30. Okay, and then tunnel source, serial interface 0/0. Okay, and then the tunnel destination will be the 64. Okay, based on our topology documentation, so that will be 64.103.211.2. okay, so let me check so that we are sure. Alright, so that 2. Okay, so let us continue. Alright, so it's confirmed. The tunnel destination is 64.103.211.2. there you go. And then the tunnel mode GRE IP, and lastly no shutdown. Okay, so let me save. Alright, okay, so let us continue the configuration. So this time let us have the static route between the two tunnel, which is the RA and the RB. So let's start with the first device, the RA. So config T, and then IP route, okay, 192.168.2.0, and then the subnet mask, of course the target destination, which is 10.10.10.2. Okay, so let us check the topology. So we have the RA, so we want to get to this network. Okay, so we want to have the communication, something like that. So that is 192.168.2.0, and our target destination is the tunnel 10.10.10.2. okay, there you go. Alright, and then end, and then copy, run, start. And how about the RB? So of course we need to declare the static route 150. So IP route, so 192.168.1.0. okay, and then the target tunnel, which is 1. There you go. So let me save. Alright, so let us analyze. So 192.168.1.0, so we want to get here from RB, and the target tunnel is 10.10.10.1. alright, so after we configure the GRA tunnel, so earlier in this demonstration we will test the connectivity using the ping command from using the PCA going to PCB. Okay, so then we configured the tunnel 0 GRA on this device. Okay, so let me use the command show running. Alright, so we have the following configuration, and for the RB, let us show run. There you go. So now let us retest if the connectivity between PCA going to PCB will work. Okay, so let me reissue the command 192.168.2.2. so that is our target host, which is the PCB. Okay, alright, so it's working now because of the tunnel that we created from the router A and the router B. So let us try once again. Okay, there you go. Okay, how about vice versa? So this time using PCB. Okay, so but first let us check the IP address of this PC. So IP config, so 1.2. okay, 192.168.1.2. okay, so ping 192.168.1.2. okay, there you go. Alright, so that's how you configure tunnel using GRE. Now let's proceed to this part, the BGP, or the border gateway protocol. So in ISP we have two gateway protocol, okay, as the routing protocol. So we have the IGP, or the interior or the internal gateway protocol. So mostly these are used to exchange routing information within a company network or an autonomous system. So this is an autonomous system, a collection or group of company network. Okay, so this is another autonomous system. Alright, so autonomous system composed of company networks. Then we have the exterior gateway protocol, or the EGP, so used for the exchange of routing information between autonomous systems such as the ISP. Okay, so let's say for example we have an ISP here. So this is the ISP belong to this autonomous system. Okay, and this is the ISP belong to this autonomous system. So the interconnections between the two is EGP, alright, or the routing information that they need to exchange. Then we have the border gateway protocol, is an exterior gateway protocol. Alright, so therefore EGP is BGP between ISP. So then every AS or autonomous system is assigned a unique 16-bit or 32-bit AS number, which uniquely identifies it on the internet. So this is the 16-bit or 32-bit assigned number for every autonomous system, as you can see in our example. So therefore, additional information about BGP. So external BGP or eBGP is the routing protocol used between routers in different autonomous systems. So in different autonomous systems, so that is the routing protocol used by most ISP. Okay, so we call it border gateway protocol or exterior or external border gateway protocol, or also known as BGP. Okay, so we have BGP here, and BGP here. So interconnections between different ISP coming from different autonomous system. And IBGP, or the Internal Border Gateway Protocol, is the routing protocol used between routers in the same autonomous system. Alright, or Internal Gateway Protocol, also known as IBGP. So routers belong in one autonomous system. They have this routing protocol information exchange. So as you can see in the example, so group of companies, connections of companies, alright, are interconnected to each other via the ISP. So therefore we can have a one or single autonomous system for that kind of interconnectivity. Okay, when to use BGP or border gateway protocol? So usually is used when an AS has connections to multiple autonomous systems. Okay, so in autonomous system, so each of these can have their internal routing protocol using like OSPF. The other autonomous system is using EIGRP, alright, and many other. So therefore, this one in this kind of setup or connections, so much better to use a border gateway protocol. Okay, so a misconfiguration of a BGP router could have negative effects throughout the internet. And how about when not to use BGP? So remember this: if there's a single connection to the internet or another autonomous system known as single home, no need for BGP. Okay, so much better to use a static route or default static route, as you can see in our example. Another is when there's a limited understanding of border gateway protocol. Okay, so it's better not to use it if you are not familiar with it. And there you have it for our lesson 3. So in this lesson, we discuss about remote access technologies that support business requirements, and also we have the point-to-point protocol over Ethernet discussion and demonstration, and we have the virtual private network. Okay, so we have two types actually. We have the site-to-site connections and the remote access type connections, and the GRE tunneling. Okay, so we have a demonstration about this technology in creating a tunnel connections between the two destinations, and of course the BGP or the border gateway protocol. So we have the IGP and we have the EGP. So these are both BGP. So remember, IGP or the IBGP is used within the autonomous system, a routing information exchange, and the EBGP, this is the routing protocol that is used between different autonomous system. Okay, so that's all for our lesson 3. See you again for our next topic.